Greetings, factoids. Get ready to get those front lobes firing. Join me and some fabulous friends as we fly face first into the Forum of Facts. This is I Know Fact All About That. The premise is a simple one. Each episode, we're given a topic we know fact all about. Each person must create 5 facts on that topic and deliver them around the table. There is a caveat. Hidden within each person's 5 facts is a fib. And at the end of each episode, we will try to fragment fact from fiction and find out the lie. Each person is researching independently of each other. We might have accidentally stumbled across the same fact. If that happens, you'll hear this noise. Fact off! Those guests will then enter a fact off, a quick fire round of 5 questions based on that topic. The person at the end of the episode with the most points has to wear the I'm with Stupid t-shirt in 5 public places before the next episode. Make sense? Great! For our first topic, we thought we'd start off small. So the topic is all of space. So join us as we boldly go where no man or woman has gone before. Joining me today are Space Cadet Bree.
Hello.
Spaced Out Nick.
Hi there.
And Give Me Some Space Roof.
Hello.
Okay, how's everyone doing?
Spaced out.
Well, let's be honest with each other. When you found out that we were talking about space today, were you excited or were you like, I know fact all about that?
Felt like it was the vastest topic to try and research.
I feel like the Google results for space facts is equal to the length, breadth, and depth of space itself. That there is endless things to read. I think I thought I had the 9 planets covered. Turns out there's 8.
It's interesting. Did any of us actually go past page 1 of Google?
Yes.
I specifically went to page 10 thinking, oh, maybe I'll find something that I don't need to fact off about.
I started looking at Brian Cox stuff and it was just far too complex. I'm like, I need a PhD to understand this stuff.
I started on the kids section.
I started on the kids section. I was like, let's keep it simple.
Yeah.
Let's keep it simple. Okay, so let's begin. Fact 1. Round 1, Fact 1, Episode 1, Season 1, Day 1. It's all ones. Okay, my first fact is the night sky is a time machine.
What? Yeah, what?
Okay, so yeah, every time we look up into the night sky, the light we're seeing, it's events that have already happened. So the closest star to us is called Proxima Centauri, and she's about 4.2 light years away. So when we see light from her, we're looking back 4.2 years in time. The most distant star we can see with our naked eye is called UY Scatii, and that is around, they're not sure, it's around 5,000 and 9,500 light years away. So the light that we can see with our naked eye, we can look back between 5,000 and 9,000 years back in time to actually see that star. So if that star has a planet around it that can support life, the light we're seeing, they haven't even started to form yet.
That's insane.
And of course, with modern telescopes and stuff like that, we can look billions of years into the future because like stars, we've got stars that are billions of light years away, and that's how we're figuring out the Big Bang and how the universe started. I thought that was cool.
Science is crazy.
It's hard to wrap your head around. I feel like I zoned out halfway through that, and then I was like, wait, come back.
Who wants to go next?
I can go. So a day on Venus is longer than its year.
Get fact. I have that same fact. Do you know how many days?
So Venus spins in the opposite direction of Earth and most other planets. The rotation is very slow. It takes about 243 Earth days to spin around just once. It takes 225 Earth days for Venus to go all the way around the Sun. Therefore, a day is a little longer than a year.
I also like the fact that you're meant to shout fact. Everybody's like, get fact. I'll fact you up. Let's do our first fact off. Do you want to do the questions or do you want to do the scoring?
I'll do the scoring.
You do the scoring, I'll do the questions. Okay, so ready. It is basically first to answer.
Okay.
So you just shout out the answer. 5 questions. You get a point if you don't answer first or you answer incorrectly. What is the name of the mission that sent the first humans to the moon?
Apollo 11.
Point to Ruth. What is the name of the largest moon in our solar system?
Absolutely no clue.
I read this yesterday.
All my troubles seem so far away.
I'm tapping out.
I was going to say, we have to push you.
Yeah,
Tick,
no.
tick, tick. Okay, it's Ganymede.
Not what I was thinking.
Who was basically, I think, that's from Greek mythology, so it's probably linked to that somehow.
Does that mean a point to both?
A point to both. Ooh. I think when we get to the number ones, closest one's gonna have to take it out. How many asteroids are there in our solar system?
825.
Asteroids in the solar system. Hang on, it's an asteroid belt around Saturn and 2 other planets. 4,000.
It says here millions. Thanks, Lauren. Millions. So, point to Ruth. What is the name of the phenomenon? What is the name of the phenomenon? Oh my God. What's it called? What is it called when a planet passes in front of a star?
A planet eclipse.
Oh, that's not a bad guess. I don't have no clue. Can't even give a guess.
It's called a transit. Eclipse, if it's something that passes between the planet and the sun, like the moon, that's an
The
eclipse.
sun is a star.
Mm-hmm.
So why would the terminology change? Wouldn't it be a solar eclipse on second thought? If it passes.
It's called transit for some reason,
Okay.
allegedly. Ask Google. I'll argue with Google. Okay, so a point to both. All right, and last one in this first fact off. What is the name of the first space telescope that was launched into orbit?
Hubble.
That is
I'm
correct.
putting myself to shame.
Launched in 1990, because I did a bit of research in this, and is still operational today. All right, we are still on round one, and Nick, we are down to your fact.
Let me fill your minds with some facts here. I thought it might be fun to talk about what happens to the human body in the vacuum of space. Bit of background. On Earth, we have gravitational forces and our atmosphere that allows us to live as human beings do here, breathe, perform our bodily functions based on the conditions here on Earth. So essentially, in the vacuum of space, we would be dead within minutes, the short and curlies of it.
I would have thought seconds. Sorry to interrupt.
So yeah, you would essentially be unconscious within seconds. So firstly, you go into the negative pressure of space. If you hold air in your lungs would essentially explode because of the expansion of the gases in your lungs. So don't hold your breath. Let your breath out. Within 15 seconds, the negative pressure would start to draw the oxygen from your blood through the tissue of your lungs through diffusion. So that unoxygenated blood goes to your brain. You become hypoxic. We all know your brain needs oxygen to perform your regular functions. So within 15 seconds, you'd be unconscious.
That would be a terrifying 15 seconds.
I'm not sure I'm not sure that gives you enough time to be able to process what's actually going on with your body. For the divers in the room, we also know that our bodies carry nitrogen.
Mm-hmm.
So the negative pressure is so strong that the nitrogen essentially fizzes in your body. So it's like an extreme case of having the bends. And all of the water in your soft tissues turns from water into liquid water into vapor. So everything swells up. So your hands and your feet would be twice their size.
God, that's awful.
That sounds like the hangover I had after my 50th birthday, can't it? I think what will happen is I'll get trapped in space and the 15 seconds will be like, what did Nick say was going to happen?
So yeah, within 15 seconds, you're unconscious. And then within a minute or two, you'd be dead. It's estimated to be about negative 400 degrees Celsius. So you would freeze over pretty quick. But for the whole mass of your body to freeze, yeah, apparently it would take about a day, which I thought was quite surprising.
I guess the assumption is you're not naked. You're probably in a spacesuit providing some sort of insulation
Yeah.
temperatures.
Well, the spacesuits stop your blood from fizzing,
But I feel if Nick was to find himself in space, he probably will be naked.
Embrace
this happen?
Yeah.
How else would you do it?
How did this happen? Okay.
Oh, that's fascinating.
That's fascinating and quite horrific.
Yes.
Do not go into space without a spacesuit.
I'm glad you mentioned dying in space. That brings me to one of my facts. So I was curious to see what would happen if an astronaut dies in space, because there are incidences where people die, unexpectedly. So I thought, well, what happens if an astronaut does die in space while on a mission? So this is basically going off the NASA protocol. So Russian cosmonauts and other countries might have different procedures. But basically, if it's not a short mission and there's an unlikely opportunity to return the body to Earth for an autopsy, if it's necessary to determine the cause of death and a funeral, so on, then the body's stored in this spatially economic space coffin, essentially. So it's been designed by, there's a Swedish eco-burial company called Promessa. It's kind of like this bag. And what it does is it constricts the body, it's so messed up, into a freeze-dried tablet of ice crystals, or essentially dust.
Huh?
So if it's because people are up on the International Space Station for months, years at a time, like if it's a long mission, if they can't get the body back to Earth, because obviously there's a risk of contamination, you can't have a body just floating around. You could strap them in somewhere, but God, Gary's starting to look the grey. That's a decomposition factor. Because inside a spaceship, the atmosphere is going to be the same as on Earth, so that you can talk, breathe, conduct your bodily functions. So the decomposition would be the same on a spaceship. So to eliminate that, rather than put them in the little lock and just send them on their way, that they can put them in this bag, and that way they can still have a funeral. I don't know what the purpose is like.
That's interesting.
Bring back your
Well, I guess
remains in some form.
it's some sort of a cremation. Yeah. Weird.
That's revolting.
It is. Well, it's probably not as revolting as just a body.
Decaying.
But that's the protocol only if it's a long mission. If it's a short mission, then they can bring them back easily enough.
We've done round one. We've had the term maintain your normal bodily functions used twice. Let's continue into round two, and we'll start with Ruth.
Okay, second fact from me. Sunsets are blue on Mars.
Ooh.
So glad no one else has that fact. So the Martian atmosphere is dominated by large-sized dust particles, and the particles cause scattering, which is something like the opposite of what happens on Earth, which filters out the red light from the sun's rays and only lets the blue light reach the eyes. So if you were looking as a human from Mars, you would see a blue sky. And on Earth, the sky is blue during the day, and then in the night it goes to red/orange. But on Mars, during the day, it's orange or brown. Then it goes to blue as the sun sets. The largest particles that are floating around, which make it go into blue, are zeolite, hemalite, magnetite, and olivite. I looked it up because I was thinking, whoa, it's going to be really bright and blue, but it's actually more of a grey with a tinge of blue.
Okay.
Not that impressive, but it's still interesting. I just thought it was interesting the fact that it's like the colours actually switch completely opposite to Earth, so it goes from blue to red.
Summertime oxide.
Yeah.
Yeah, so it's sort of, the planet's made up of rust.
Okay, Nick, fact two.
This is interesting. Okay, so in the sky, in Earth's sky, the sun and the moon look roughly the same size. This is because the sun is both 400 times further from Earth than the moon is, and the sun is 400 times larger than the moon. So this is why when we have an eclipse, the moon almost fits perfectly in the diameter of the sun. To add something more to that, the moon isn't always consistently the same distance from Earth. So that's why sometimes during an eclipse, you can see the halo of the sun around the moon.
It's so funny as you're delivering that fact and you start on the numbers, my head starts to do the maths and then go, oh, no, it's space maths. It's the numbers are too big.
Isn't that a remarkable coincidence? If it is a coincidence that from our perspective, that it is that Goldilocks zone that you read about with XYZ, that the sun and the moon appear the same, that we can have these eclipses that were worshipped by so many tribes throughout history and so on, that they're the same out of all these random numbers and the randomness of space that they talk about, that they are, from our perspective, the same.
Perfect, almost. Yeah.
Almost perfect. Astonishing. Anyway, good fact.
Makes you think about the randomness.
Is it
For sure. That's what I mean, yeah.
pure chance?
No, it was programmed. We're living in a civilization.
Total simulation.
Yeah. And Brie, fact 2.
Someone will probably have the same fact, but I found it interesting that outer space, in a general sense, is only 100 kilometres away. So obviously there's no solid boundary that you're pushing through to define outer space. The Kármán line is a proposed conventional boundary between Earth's atmosphere and outer space. It's not universally adopted. 100 k's isn't that far. You could walk there on a good day.
That's like from here to Brisbane.
Yeah, it's astonishing.
That sounds
Pretty much.
insane, yeah.
So I think that outer space is only 62 miles. For those American friends listening in, that's astonishingly close to think. All of that out there, all of this stuff is just there.
Okay, that's interesting. 100k, you could make it in an hour, or an hour and a half in the Prius. Okay, my fact 2. Comets versus asteroids. Are they different? And they are. Asteroids are usually made out of rock and metal, whereas comets are made out of ice, rock, and dust. They both are celestial bodies that orbit the sun, but asteroids tend to be in a fixed orbit, the asteroid belt that Brie mentioned before, between Mars and Jupiter. It's kind of a stable orbit, so they stay there, whereas comets move in more of an elliptical orbit, so they go close to the sun and come closer to the Earth. That's why we get comets like Halley's Comet, the famous comet. Comets also tend to have the tail behind them, whereas asteroids only really get that tail when they're entering Earth's atmosphere to destroy all life on Earth.
Wow.
It's theorized that most comets we see come from the Kuiper belt, which is a belt beyond Neptune, or the Oort cloud, which is theoretically right at the edge of our solar system. It's like a bubble surrounding our system, and it's made up of rock, ice, and dwarf planets.
I'm so impressed that you had all that off the top of your head.
Yeah, so am I. I'm just going to look at my notes. Did I actually miss anything? Oh, yeah, I did. Sorry. Asteroids are believed to be leftover materials from the formation of the solar system.
So it's like the residual leftovers after,
Something smashed into, a moon smashed into another moon, stuff like that. Well, that was a good round because we didn't have any fact-offs, and I learned some stuff for sure. Okay, let's go on to fact 3, and let's start with Nick.
So it turns out there's a planet in our galaxy that is made almost entirely from diamonds. The name of the planet, it's a bit of a tongue twister, PSRJ 1719-1438b. This planet orbits around a pulsar. Now, a pulsar is essentially, it's a rapidly spinning neutron star. So think of a pulsar like a lighthouse in space. So radiation is emitted from the poles of a pulsar, and as it spins, the radiation flashes on and off. It's thought that the planet was part of a much larger galaxy that was ripped apart by the pulsar's intense gravitational forces, similar to how diamonds are formed on Earth. The same process was applied through the help of this pulsar to create this diamond planet under very similar forces, but at a much greater scale.
How far away is it? Do you know?
I'm
Too far.
Roofs after a neutron?
Because I read that fact, but I didn't research it at all, so that was really interesting.
I didn't get the distance, but like anything in space, it's a long, long way away.
Apart from space itself.
That's right, over 62 miles for those who didn't.
So my third fact, the furthest star in our galaxy is called Lacona Celerala, and it would, with current space travel, take us 79 million years to get there.
That's astonishing because rockets, as far as I understand, travel really, really fast. So 79 million.
Like, it makes you think that, I don't know, when I hear numbers like this and when I think about how far just things in space are, it's like, at the same time, it makes me overwhelmed and feel like oh my God, there's just too much out there. It's terrifying. But then at the same time, there's like this comfort of like, we're so insignificant, doesn't matter. Like, it's like, there is so much out there that your problems are, they're so simple and small, and it makes you just get a bit of perspective into like, you know, if you're angry because you're late for work or something and there's like a car in front of you that's slow, it's like, doesn't matter. You know, in the grand scheme of things.
Okay, so I've got a fact for you. I found this very funny. Probably not that funny. Eugene Aldrin Jr., so commonly known as Buzz Aldrin, the second man on the moon. Ironically, Moon was his mother's maiden name.
Interesting.
Get out of town. Isn't that funny?
That is funny.
Did that plant a seed in his mind to become an astronaut?
I don't know.
Subconsciously.
I wonder how the world, because he was born in 1930, I think, and I wonder what, you know, space was such an exciting frontier then. I'd be curious to see what the general attitude was to space travel, you know, when he was a youngster, what pushed him into it, how welcomed it was as a career.
But it wasn't even thought possible.
Yes, yeah.
That hadn't happened.
Parents are going, you know, you should go work at the bank or...
I wonder what a good precursor is to being a suitable candidate to be an astronaut.
Surname, tick. Well, no, it wasn't his surname. It was his mother's maiden name. But yeah, that was probably on the form somewhere to complete at NASA when he was signing in that they thought, you are the best for the job.
Family history of varying in the... No.
I have no experience landing on a moon, but my father landed a moon.
Oh, God.
Nice one, Bree. Sharp.
Okay, fact 3 for me. The Great Wall of China is so large it can be seen from space with the naked eye.
Backed off.
Oh. Well, it's 13,000 miles long. It's one of the biggest man-made structures on the planet. It's not the only man-made structure on the planet that can be seen. Do you know of other man-made structures that can be seen from space with the naked eye?
Is it the Palm Island in, I want to say, Dubai?
I've actually been on those islands. And yep, you can see the Palm Islands. You can see the Great Pyramids of Giza from space. They're some of the oldest man-made constructs on the planet, and they're so big that you can actually see them from space. Yeah. And you can also see, I have to check the name here, the greenhouses of Almeria, which is in Spain, and it's 100,000 hectares or acres, of greenhouses.
Wow.
Which is basically the food bowl for Europe. And you can actually see that from space, all the glass and the plastic and stuff like that.
That's insane.
All right. It's a fact off time. Who's going to read the questions? Who's going to do the scoring?
I'm going to read.
Oh.
I just can't wait for someone else to be going here with me.
Oh, no. Lauren's written.
Yeah, I have not seen these.
Okay. I was going to say there'd be a slight
Yeah. If I get 5 out of 5, then...
Okay, are we ready? Question number 1. How many moons does Jupiter have?
3.
85.
Okay, it's 79.
Are we going to go
Point to Nick.
Yeah.
What is a black hole?
It's essentially a void in space.
The collapsed star.
I don't know if either are correct.
It's formed when a star collapses, but it's not a collapsed star. It's the void that's left over after.
So did anyone get that?
Well,
you both
get a point there, I think. Yeah.
What is the name of the spacecraft that landed on Mars in 2021?
Beagle. No, not Beagle. Beagle was earlier. Beagle was the British one. Oh, then that was Beagle 2, I think. No, I don't know.
I'm going to say Rover, but that's the little, the thing that's been cruising around taking photos of Mars.
Yeah.
And what was it?
Perseverance.
Oh, I did not know that. No.
Wouldn't have got that.
Beagle or Beagle 2 definitely landed, but that was the British one that kind of, I think it crashed landed into Mars. America went, "Hey, we've landed," and British went, kind of made it here. We have a flag.
Okay, question number 4. What is the name of the force that keeps planets in orbit around the sun?
Gravity.
Boom. Yes, correct. How long does it take for the moon to orbit around the Earth?
A month.
I read this.
like-
I'm going to say 29 days.
You're closer. It's 27.3 days. Good job.
How's that t-shirt looking? Ruth, you are not alone.
I am so happy.
What are the scores, Brie?
So I'm sitting on 2, Nick's sitting on 5, partnering Ruth with a high probability of wearing shirts. And Kieran, you're on 2 as well.
Let's just high five there. Okay, let's move on to fact 4 and let's start with Brie.
So another NASA protocol. I got stuck on NASA protocols. If a NASA astronaut becomes untethered during a spacewalk, the protocol is to use their emergency jetpack to counter any tumbling and stabilize themselves. So basically, if you are Sandra Bullock and working on the spacecraft and an asteroid comes, because the astronaut is weightless, they're going to move and spin out of control to match the force that was placed upon them at the time of untethering. And being a vacuum, no amount of kicking or failing, you think, just kick your legs, Sandra. No movement will stop that. So the astronauts have that jetpack with the acronym SAFER. So the SAFER jetpack will automatically stabilise themselves so that they can neutralise themselves. Then they need to take manual control, try to manoeuvre back to the spacecraft, just because with the right angle and velocity, the astronaut may, this is terrifying, may even fall back to Earth and burn up in the atmosphere. Like if they are pushed in a direction towards Earth, you're just going to keep going.
Oh my God.
Yeah. Oh, I guess.
Do they have a limit as to how much, I guess, gas is in the suit to be able to propel them?
Yeah. So with the jetpack, they may be able to, this is a big, this is the key word. They may be able to manually fly back to the spacecraft. However, the jetpack only carries just over 1 litre of fuel. So once that runs out, unless another astronaut has grabbed them, you are on your own. So the spacesuit, you just have to enjoy your orbit. Funnily enough, you've got within the suit, it's got approximately, obviously this is similar to scuba diving, how much air is in your tank is dependent on your rate of breathing. So, but you've got approximately 7.5 hours of oxygen, and you've got a litre of water that you can give a little sippy straw in the helmet. But that 7.5 hours of air will let you see approximately 5 sunrises and sunset.
I wonder if it works the same way as a scuba diving rebreather, as in the fact that the oxygen's recycled and scrubbed.
I wouldn't want it.
CO2.
Yeah, quite possibly.
I wouldn't want it to.
I was reading a little bit about spacesuits, and the American NASA spacesuits cost $12 million. And I think it's 10 million or 8 million is just on the back, on the jetpack part, basically.
Wow.
But if they can get to the diamond planet, it's going to eliminate the cost of it. They can afford to
We
make
could all have a spacesuit. But spacesuit for everyone on Earth.
But what would you do? You know, you'd want a little red pill in there, wouldn't you? If you knew that that's it, you just probably open your eyes. But then again, that's going to take 15 seconds to a few minutes
Well,
to die.
Well, at least you'd be unconscious within 15 seconds.
Yeah. That's obviously provided that whatever impact made you become untethered didn't kill you on impact or damage your suit irreparably, that, you know, you're not.
I think I'd just like some kind of relaxing psychedelic drug. Put on some David Bowie, Major Tom, and just float on by.
Because there is no resistance in space, say you take off in the opposite direction to Earth, you would essentially eternally be traveling in that direction, dead or alive. There's nothing stopping you unless an asteroid or a meteor.
Well, I guess eventually you probably come across some sort of.
You do hit particles, even tiny particles, surely, because they would affect you at some point. They'd affect your balance.
And you'd get pulled into some sort of gravitational pull, presumably.
Get
And then-
smacked straight into a black hole. That's
It's interesting. Okay, fact 4.
So apparently space smells like seared steak.
That seems like an outright lie. Who's taken their spacesuit off to smell it?
That's what I was wondering.
Well, according to astronauts, the smell of space is often described as similar to the smell of seared steak or hot metal. This is thought to be due to the presence of various chemicals and compounds in the vacuum of space, including atomic oxygen, ozone, and nitrogen.
I wonder, could they, on their spacewalk while fixing spacecraft, Could they take just a big glass jar, open it up, fill it with space, bring it back and have a whiff?
Maybe that's how they've done it.
I never knew space would have a smell.
It surprised me. Yeah, I would have thought, being that it's a vast nothingness, that it'd be a neutral odor.
But there's so many gases out there, like you mentioned, and hydrogen and nitrogen, are they the most common? What's the really smelly one?
Like sulfur or something.
Sulfur. Okay, interesting. So it smells like seared steak. I'll go fact 4. Earth is the only planet in the solar system that is not named after a Greek or Roman god. And so we have Mercury, that was named after Mercury, and it's called Mercury because it travels so fast. We have Venus, who's the brightest planet that we can see with the naked eye, so it was named for her beauty. Earth was not named after a god. Mars is named after the god of war because of the colorization of red that reminds people of blood. Jupiter is the king of the Roman gods. Was Zeus, turned into Jupiter when it went to Roman, and Jupiter's the biggest planet. That's why it's named the king. And Saturn used to be called Cronus, which was the Greek god, but it's now named Saturn, and is the god of agriculture. It's meant to remind people to be patient because Saturn is a slow-moving planet when we observe it from Earth. Uranus is named after Nick because you're an ass. And
Thanks, Kira.
no, Uranus, and I just wanted to say Uranus. Uranus and, or Uranus, however you want to say it, and Neptune were discovered later in the late 1800s, early 1900s, I think. But they were just given Greek or Roman god names because that's what we've done.
That was the status quo.
Yeah. Uranus is named after the god of the sky, and Neptune, because of its blue and icy, I think is named after the Roman god of the sea. But Earth comes from an Old English word. I've got it here. I'm going to say it. Aroi. I don't know. So it's linked back to Old English time, but because it wasn't named by a civilization or a person, wasn't discovered, we don't really know where the name Earth comes from, which is weird because we live here and we don't know.
Let's just make it up here and now.
Yeah.
I read this fact, and the website that I got it from said that Earth was derived from, it was a culmination of Latin and Old Germanic word meaning ground.
The Old English means dirt and ground as well. So
Okay, so astronauts can actually grow taller in space. This is due to microgravity. When the spine is not exposed to the pull of the Earth's gravity, the vertebrae can expand and relax, allowing astronauts to grow taller. But when they return to Earth after a few months, they go back to the same size.
I just sat here with my spine forward going, wouldn't it be nice just to have no gravity on this baby now? So that's good. How much taller?
I didn't say, well, I'm sure I could have researched more, but I did not. I guess it's like how much pull is inside each vertebrae, so it couldn't be more than a few inches, I'm sure.
And is that the only thing that grows?
Who knows?
It's a valid question.
Hair, obviously.
Nails. Fact 5. Space is really big.
Tell us more.
That's my fact. But we can calculate the mass of the whole universe. And do you know how I know this?
Brian Cox.
Because a few years ago, Bree and myself and a gang of us went to see Brian Cox. And Brian Cox explained how they figured out how to measure the mass of the whole universe. And we all fell asleep.
Just say it's not a universe, it's a multiverse.
A multiverse. And I fell asleep.
I fell asleep.
It's that, honestly, it was so much science and so much numbers. Sarah fell asleep. We all fell asleep watching Brian Cox. We all kind of come out of it, didn't we? Good.
To think of the money we spent on these tickets thinking it was an interesting talk. And I'm sure it was fascinating if you're an astrophysicist, but it was an actual lecture.
Yeah, like a full-on
lecture. Nothing but algorithms.
Your brain is just...
Do you have some toothpicks for this next fact?
I certainly do. So basically the way they calculate, there's a few ways they calculate the mass. Number one is by studying the velocity of galaxies and stars, how fast things are moving away from each other. Background radiation from the Big Bang. They study how much of that is in the solar system. Also, how gravity of large objects affects other objects. So they're able to calculate. They use a kind of a combination of all of these things to actually get to the answer. And the answer is here. I don't know how to pronounce this as a mathematical thing, so I'm just going to pop it down below here. It starts with 3. The universe is made up of 5% matter, us, the table, the planets. Yep, all of that stuff. 27% dark matter and 68% dark energy. Ooh. Which, number one, why did we have to call it yet? Why call it dark, black hole, dark energy? Die in space.
Space is just full of neg vibes.
Yeah, pretty much. So dark matter does not absorb light and does not reflect light. So we can't actually measure it with any of the instruments that we have for measuring stuff. But we know it exists because we can see its gravitational pull on normal matter. So we do know it exists. And dark energy is hypothetical at the moment. So it's basically the space between everything else, which is making the whole universe expand from the Big Bang. So although we haven't actually proved its existence yet, we're pretty sure it does exist, allegedly.
Wow. With all of this, it just blows my mind that I can't even, what you just said, just flew over my head. And yet we have studied more and know more about space than we know about our own oceans. That just blows my mind that all of this stuff is more than we know about the Mariana Trench.
It's pretty crazy.
Off the coast of the Galapagos, it's astonishing.
But since the Big Bang, isn't the universe expanding in all directions
As fast as it can whiz.
Yeah. So essentially, those numbers they were maybe right for a time, but with the continual expansion, that number could be infinitesimally larger as the universe expands.
Yeah, well, this is it. It's changing all the time.
But doesn't the velocity come into that? Because at the rate of things moving, it would be a constant recalculation. Like they'd be able to work it out based on the velocity.
Well, this is it. I mean, like if the universe is comprised of stuff, whether it's dark energy, dark matter, normal matter and stuff like that, it doesn't get added to the more it expands. What's beyond the known universe? Do you know what I mean? Do we add more? Is more added the further it expands, or is it just moving further apart? And if it moves further apart, what's in the middle? Does that make more dark energy, or is it just nothing? It's above my pay grade. That's all I can say.
I suppose the laws of thermodynamics, one of which is energy cannot be created nor destroyed, only transferred. So that energy, that initial burst of energy will never change as such. It will just transform in its form and function.
Yeah. Which is quite crazy as well. It's like how much energy was there to actually create this? Because even the energy it took to create this room wasn't a lot. Do you know what I mean? When we're dealing with the whole universe, it must have been giant. Yeah, it's just mind-blowing. Okay, so that's my fact 5. Who's next?
I can go. I thought this was super interesting. So Earth belongs to the Milky Way galaxy, which has over 200 billion stars. But in the very center, at the galactic center, is a supermassive black hole. And the supermassive black hole contains about 4 million solar masses, which are all come together to be called Sagittarius A, which almost led me down some other route, but I stopped myself there. And the black hole, so a supermassive black hole is deemed as a black hole with a mass of over 100,000 something. I didn't get the measurement. I just realized. I was like, 100,000 what? That was my fact.
So at the center of the Milky Way. So the Milky Way is that's it with the spiral galaxy. We've got the spiral arms coming off. We're on the outer spiral. I know that because of a Monty Python movie.
Whenever life gets you down.
But right in the middle. At the middle. It's interesting.
Massive black hole. And it says that all galaxies start with a supermassive black hole in the middle.
I thought this was interesting for a comparison because, as I've probably said 42 times in this, I can't wrap my head around this topic. But a group of scientists estimate that if the sun were the size of a blood cell, pretty small, then the entire Milky Way would be the size of the USA.
Whoa.
That just bent my mind a little bit.
It's just, and that's only the Milky Way, and we are one of hundreds of thousands of millions of galaxies in this endless time-space continuum, and it just doesn't stop. You still have to go to work on Monday.
Yes, bugger that.
As we come to the end of episode 1 of I Know Fact All About That, it's time to find the fibs. So what we'll start with, Brie, I'll ask you what you think my fact was a fib.
Are we allowed a recap?
You're allowed to recap. Would you like me to recap you?
I would love for you to recap me.
All planets are named after Greek and Roman gods apart from Earth. You can measure the mass of the universe. You can see the Great Wall of China from space. You can tell the difference between an asteroid and a comet, but maybe not a meteorite. The night sky is a time machine.
I feel like that all true. The fact that I fell asleep through Brian Cox means I can't verify that fact, and I feel like he wouldn't lie to us because he's too good of a man. I think they're at the point of being able to admit that they can't do it, but they're close. But I don't know that you can acutely know for sure.
And Ruth?
Nominate your fact.
Mm-hmm.
Night sky is a time machine.
Okay. I can't ask Nick because my lie is the Great Wall of China can be seen from space. It's a lie. It's an urban myth.
I read that it was lies.
No, not with the naked eye, because although
I didn't hear that disclaimer.
very, very long, it's very, very narrow.
Yeah.
You can see it with cameras and telescopes, but not with the naked eye.
If an astronaut in space has a pair of binoculars, they can see it, but not with the naked eye, without some sort of visual aid.
Whereas with the pyramids and the greenhouses and a few other, not the Great Barrier Reef, of course, and stuff like that, you can, at Lake Superior, you can see from space, but not the Great Wall of China. So that was
I guess it comes down to where you define space, which is
100 kilometers. Okay, so that was my fib and Nick's fib. Let's try to decipher what Brie's fib was. Can we have a recap? Because all of yours sounded plausible too. As I sat here when you all read them out, just going, yeah.
the protocol about someone dying in space, going into that Swedish, the fancy dust creating, crushing space bag.
Now, when you say it again, okay.
Yeah, that sounds rubbish.
Smell something.
It has a steak. Something smells like steak. It's
That's why you stick your name on Tinder.
What you're smelling is all the Promessa, what do they call them? Spatially economic space coffins. Look it up, Swedish eco burial company. Then I had the joint one about Venus being a day being longer than a year. Space is only 100 kilometres away. Well, that's the determination of the Kármán line. Buzz Aldrin's mother's maiden name was Moon. The NASA protocol on what an astronaut does being untethered. And then that little bonus fact was scientists comparing the sun to a red blood cell.
I think I've heard something about Venus, about it being like that, but I'm not totally sure. The coffins, are they see-through? Are they got kind of black see-through back?
I didn't see a picture of it.
Are they going to be...
I think so, because that would be messed up on so many levels.
Watch them deteriorate.
Yeah, remains to be seen.
I don't know how long I've seen the
Sorry. So space coffins, blood cells.
I think his name wasn't Moon.
Moon could be also one, because I didn't research any astronauts, so all right. We're all pulling a moon at you, Brie.
No, the moon is right. It legitimately was his mother's maiden name, which I found really funny. No, the lie, dun, 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 the space coffins. So the technology they are working on at the moment, but they're not there yet.
Okay, as Ruth.
Space.
Right, ready for a recap. So I had the fact that I shared about the Venus days, years thing. Sunsets are blue on Mars. The furthest star in our solar system is 79 million years away. Astronauts can grow taller in space, and the supermassive black hole at the galactic center of the Milky Way.
It's either the far star, because you said solar system again.
We've only got one star in our solar system.
I'm like, yeah, because I wrote solar system / galaxy the first time.
The Venus one is obviously true, because Brie had the Venus one. I've never heard about the blue sunsets on planet Mars, but I've never been there. Mars, Milky Way, galaxy. I'm just craving chocolate.
I would have thought we would have maybe seen something
or heard something about blue Mars.
Yeah, that sounds like almost a common knowledge thing if it was.
Maybe Nick's right. Maybe it's the sunset. I'm going to sunset.
And you're going sunset as well?
Yeah, I think so. Blue sunsets sound like
farcical.
We would have heard about in pop culture.
I would say that the blue sunset's true. I'm doubting the supermassive black hole in the middle of the Milky Way, because if it is in fact a black hole, to my understanding, then I feel like we'd all be moving in, not further away, you know. But I feel like it would be the opposite, that if every galaxy, as you so claim, had a black hole in the middle, because I only just found a black hole.
Would that not depend on how much force is pushing it away, though? Even if it's a black hole and the forces there are astronomical, if the force from the Big Bang, if it's bigger, it's still going to push things away.
Counteract that force.
Yeah.
I feel like a supermassive black hole would be more powerful than a standard black hole.
I really hope Brian Cox watches it. Just sitting there going...
Shaking your head. It's a fella's place, but he got our money anyway.
Yeah, maybe you guys should start a boy band or something.
You should definitely tag Brian Cox as well.
Okay, Ruth, reveal your fib.
You're all wrong.
Oh,
You should have went with your gut instinct. The furthest star was a load of bull.
No.
And I had to actually change it in the middle of today's episode because you messed up what was going to be my lie fact by telling us about the closest star. That was going to be my false fact, which I was going to say is the furthest away star. Then I had to change it and make up a whole new name and make up a whole new distance. Tell you it was the furthest away star, so that was a lie. The rest are all true. And actually the sunset on Mars is really interesting to look at.
that's what I'm going to be doing this evening.
Google that picture. But what you said about, like, how is there a supermassive black hole? I actually want to research that now. I'm like, yeah, how are we all not getting just pulled in?
Yeah. Well,
It's getting closer.
we're, as Kieran said, we're out on one of these arms of the...
We're 30,000 light years from galactic central point.
Well, there you go. So that's a lot of time for things to get...
According
For the bathwater to empty. And the ball gets stuck down. Okay, so we have on joint 5 points, Nick and Ruth. So we're going to have one final fact off, unless they both get all 5 questions wrong, in which case we'll have another fact off. Okay, so are we ready, guys?
I'm doubting any facts I've ever known.
Bree, when you're ready.
Okay. Fact off. Number 1, what is the name of the largest volcano in our solar system?
Don't know.
I have no idea.
The answer is Olympus Mons.
And it's on Mars, and it's 22 kilometers high, and it's almost 3 times the size of Mount Everest. I was going to use
What was this? What's it called? Olympus?
Olympus Mons.
Olympus Mons. All right. Remember that one.
What is the speed of light in a vacuum? And I'm looking for an answer to a whole number.
And you can't go and look in the Dyson.
I'm just going to warrant a guess. 2 billion.
Am I able to ask what the measure...
In meters.
The unit of measure?
Meters.
Meters or...
Meters per second.
Meters per second. Okay. 300 million meters per second.
Correct.
Well,
Good job.
Ruth, you've just snuck ahead.
How long does it take for the Earth to orbit around the sun?
A month.
365 days.
You're both wrong. Think about it and then come back to us with your correct answer. Are we allowed to give a clue? Just to see if they get it.
I'll give a clue. Think about there's 1 month of the year.
28 days.
No. 3 years?
Oh my God. You're stupider than I thought.
Okay. So we need your answers now, and the closest wins.
Okay, let's just say 4 years.
365 days, except for in a leap year, which would be 300.
64.
64. So it's 365.25 days. So there's a quarter day.
Every 4 years, so that's why we get...
That's where they account for that extra time, that it's a quarter. So it's every 4 years that they make that adjustment. Okay, what is the name of the brightest star in the night sky?
The North Star?
Can't be serious.
Helios something.
I was about to do that joke.
It's serious.
Oh, serious.
Yeah,
Right.
serious.
Well, is there any point
Spelled
going? Guys, I'm lost.
Oh yeah, no, we have to slaughter the lab. We can't just wound it. We have to finish it off.
Drop that dagger in. Okay. What is the name of the first artificial satellite launched into space?
I can't even posture a guess.
Sputnik 1.
Oh, real
Launched in 1956 or 57, which forced President Eisenhower to form NASA in 1958 in retaliation to the Russians' space race. Wow. Interesting. Okay, so Ruth, you will be wearing the T-shirt. So we need, before the next episode, we need 5 pictures of you wearing this T-shirt in public.
Yeah.
Okay?
Shame to me.
Shame. We follow. Shame. Shame.
Thank you all for watching. We will be back next month with a new episode. And what we're going to do right now, the people didn't know we were going to do this, but we're going to do it. And we're going to give you all a chance to choose what the next topic will be. And the people down below who comment and say how would like it to be Bree's topic or Nick's topic or Ruth's topic is the topic we will cover. So Ruth.
The human brain.
Oh, the human brain. That's a good one. Okay, Nick.
Volcanoes.
Oh, volcanoes.
The Mariana Trench.
All right. So we have a choice of the human brain, volcanoes, or the Mariana Trench. Okay, as we round this out, I would just like to say thank you to Ruth, to Nick and Bree for joining us today. And comment down below, guys. Let us know if you want us to cover one of the topics mentioned. Thanks for watching, listening. I was trying to think of what touching. What other senses are there? Tasting. Thanks for tasting us. That's all.
Do you smell the steak? It's sizzling of steak too.
It's all good fun. Okay, bye, guys. Bye.
Bye. Yeah.